My name is Collin Lee. This is my arc length presentation for the AP Calculus AB arc length project. So this is what I used. This is my path that I chose, which is a simple walk from my town's cafe, Cafe Angelique, on the bottom right of the image, to a shady park, Roosevelt Commons, which is on the top left of the image. So based off of this, I decided to take 10 points from this simply because it's just a very easy number to use, and the distance from the x-coordinate of the commons on the top left to the x-coordinate of the cafe is around 1,668 feet. So since we're starting with the commons at 0, we had to take the next points at around 185 foot interval. So that was what you got when you divided 1,668 divided by 9. So using that and using the new measure feature in Google Maps, these are some of the points that I calculated. So as you can see on the top image, these are some of the points that I had. And the starting point, as I said, is the commons, which is at 0, and a y coordinate of 1,230. And as you can see, as they go further across, the numbers slowly start to become, or as the x values continue to get higher and higher, the y values continue to get lower and lower, with eventually the ending point at the cafe being 1,668, 0. So using these points, I was able to calculate a best fit line using a quadratic equation regression. Now initially I wanted to try to do a 1 over x regression, but unfortunately there was no such thing on the TI-84 graphing calculator that I had. So the next best option that I had was the quadratic equation regression. So these are the variables that I got. For A, it was 5.148790753 e to the negative fourth. Unsurprisingly, considering the fact that this graph, or the y values, continuously get lower as the x values get higher. For my B, it was negative 1.605 over 6412, and for my C variable, was 1,261.069713. Again, not surprising considering that our first point was 1,230. So, given that, I was able to use the arc length formula, which is the integral from a to b, and this, all the square root of 1 plus dy dx squared. And using the derivative of our equation, this is the equation I put in, and the range of values that I used for this interval was 0 to 1,668, since we are taking this with respect to x. And the final answer that I got, as you can see in this image, was 2,191 feet. Now, as I said before, the arc is about 2,091 feet. So for reference, the path length measured about 0.472 miles, which translates to roughly about 2,492 feet. Now, the reason why this is a little bit off is because one of the points didn't really follow the regression line. As you can see, the third point, which if we go back a couple slides, is 371,920, is much higher compared to the subsequent point and the previous point. So, unfortunately, if we had a different point, we maybe could have gotten a better regression line that could have also fit maybe the length a little better. But that is it for my arc length presentation. Thank you very much for watching.